Hello children, in this video let's work out the second sum because the first sum has been worked out in our earlier video. The second sum, you should find the zeros of 4s squared minus 4s plus 1, and after finding the zeros you should verify the relationship between the zeros and the coefficients. So first, for finding zeros, we know that to find the zero of this quadratic polynomial, we should find that value of s. That value of s at which the whole polynomial becomes equal to 0. And being a quadratic polynomial, it can have at most two zeros. Let's start solving. So let's split the middle term into two terms in such a way that the sum of the terms is minus 4, sum should be equal to minus 4, and the product of the term should be equal to a into c, which is 4 into 1, 4, right? So 4s squared minus, now just find the factors which satisfy these two conditions. So the sum should be minus 4, right? And the product should be plus 4. So 4 into 1 is not going to satisfy because minus 4 plus 1 would be 3 and not minus 4. So why not take minus 2 and minus 2? The sum is, yes, minus 2 will give you the middle term, and the product minus 2 into minus 2 is equal to a positive 4. The product has to be a into c, positive 4. So let's do the splitting. Minus 2s plus 1 is equal to 0. Now, in the first two terms, we can group it together, and the third and the fourth term can be grouped together. Take the common factors in the first group. The common factor is 2 and s. So the rest would be 2s. You multiply 2s into 2s, you get 4s squared minus 1, right? And what about the second group? Yes, if you have 2s minus 1 within the brackets, you have to factor out minus 1. Only then you will get minus 1 into 2s is minus 2s, minus 1 into minus 1 is plus 1. So, all of this equal to 0. So, now 2s minus 1 being common to both the terms, that is factored out, and you have 2s minus 1 in. So, you have, in this case, you see that 4s squared minus 4s plus 1 has been factorized into two same 2s minus 1 and 2s minus 1. So, this is a square, okay, this is a perfect square. So, and you have repeated zeros. How do I say that? So, if 2s minus 1 is equal to 0, you have 2s is equal to 1 or s is equal to half. Same here also, s is equal to half again. So, these are repeated zeros. Now, do the verification. As I said in the last video when we did the first sum, this is the general form, ax squared plus bx plus c is equal to 0. The relationship is the sum of the roots. If roots are alpha and beta, the sum of the roots should be equal to minus b by a, and the product should be equal to c by a. So does this satisfy? Is this relationship satisfied here? What is the sum of the roots? Half plus half. Half plus half is equal to 1. But what is minus b by a? My b by a is minus 4. Let me write it separately and show you. B by a is minus 4 divided by 4, right? Which is equal to minus 1. So, this is equal to minus of minus 1. So, it satisfies this condition, minus b by a, right? So, half plus half is equal to 1 is equal to minus b by a. This is equal to minus b by a. So, this condition is verified. What about alpha into beta? It should be equal to c by a. So, what is your c by a? First, let's arrive at c by a of this equation. It is 1 by 4. So, 1 by 4. And what about if you multiply half into half? Those are the roots of our equation, right? You get 1 by 4, which is C by A. So this is also verified. I hope it's clear to you. Thank you.